అయినట్టే కదా గెలిక. Hello. Array, is it audible, right? Hello. బ్రేక్ తీసేసావా? పర్లేదు ఉంచలే ఓపెన్. Right, Nana. So last class we are discussing that isomerism, right? In isomerism, we discussed that geometrical isomerism, cis and trans isomers, EZ, and boiling point, melting points, polarity, dipole moment, and counting of geometrical isomers in case of symmetrical and unsymmetrical cases. And today we will put the heading allenes, Nana. Allenes. Allenes means when cumulative double bonds. Generally, alkenes are three types: cumulative, right, isolated, and conjugated, like that. Cumulative double bonds are there. In this cumulative double bonds, for example, A, B, C, D. Is this showing the geometrical isomerism? No. Why? Right? It is not showing the geometrical isomerism. Why, Nana? Both are perpendicular to each other, right? Like this. So for example, A, B, C, D. No. Both are perpendicular. For example, we know same side means cis, opposite side means trans, right? For example, try to understand, it is A, right? Imagine this side is C. Both are perpendicular. We can't say cis and trans. In case of even numbers means here is 2, 2, then 4, 6, 8, dash, dash, dash case. It won't show the geometrical isomerism. But what exactly happens? Hello? In case of odd number of double bonds, odd number of double bonds, AB, for example, CD. Odd number of double bonds, what exactly happens? Both are in the same plane. So one is in this plane, one is perpendicular, one is same plane. So now either one double bond or three double bonds or 5 or 7 or 9 dash 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 cases is equals to, they'll show the one geometrical isomerism, and same A is not equals to B and C is not equals to D, then only it apply, right? Condition A should not equals to B and C is not equals to D. Write it down. అని రాసావా? ఎన్ని వచ్చాయి? నేను కొన్ని ఇచ్చాను, 25 అని తెచ్చాను. Right, Ram. So here is once again I'm telling, in case of allenes, allenes, even number of allenes, both are perpendicular to each other, they won't show the geometrical isomerism. Odd number of alkenes, 1, 3, 5, 7, 9, those cases will show the geometrical isomerism. Got it? Hello? Right, Ram. So for example, count the geometrical isomerism, the isomers. Yeah. Count the number of geometrical isomers for this. Come on, do it. Meghna, are you listening? Meghna. Okay. Is it comfortable online? Okay. Yeah, I know. Completed? How many now? So this one will show the geometrical isomerism. This one won't show the geometrical isomerism, right? And this one will show, right? 2 power 2, 4. Okay, any doubt, anybody? Then Nana, try to write one more. Yeah, count the isomers. And tell the class timing. Yeah, count it. So in this case, is it showing right? This one will show. This one? No. This one? Yes or no? No. Why? Both are same. So 2 power 1. 2. Now this one? This one? No. This one? Yes. This one? Huh? No. Even number. Right? So what we need to consider, once again I am just telling, whenever the even number, right? Even number are coming, it won't show the geometrical isomerism. Even number of allenes, because both are perpendicular to each other. So even number of allenes are coming, it won't show the geometrical isomerism. Odd cases, we need to consider total is 1. Done? So in this case, it's showing, because it is even number, it won't show. So this is the odd number, 1, 2, 3, it shows the 2 power 2. In this case, same. Okay, it will show, it won't show, because this is even number and this is odd number, it show, but C is not equals to D. So we need to consider all these things. So a lot of people, 90% of students are doing the silly mistakes in these particular cases. So they know how to calculate, they know the formula and everything, but in case of allenes or some cases, so they'll do the mistake. In this case, actually it's an odd number, it shows, but A is equals to P, it won't show. In this case, it shows, right? It won't. So 2 power 1, 2. Right? Any doubts? Hello? Yes, Nana? Clear? Hello? Who told something? Nana? Hello. Next, oximes, Nana. Sin and anti. Sin, anti. So generally, aldehydes are ketones, Nana. Aldehydes are ketones when treating with hydroxylamine. NH2OH. What products we will get basically? So water is going like this, directly I am writing the product. We'll get the product or CH double bond N. Actually nitrogen is having one lone pair, right? It is OH, the lone pair. Okay, so it oximes, this we called as oxime, right? This oximes will shows the geometrical isomerism. Sin and anti, how should we say? For example, if I am taking the CH3, C double bond OH, right? Directly I am writing, it is one OH, lone pair, right? And CH3, H double bond N, lone pair here OH. Now, this is what, if in case of aldehydes, this is aldehyde, right? We have aldehydes and ketones. In case of aldehydes, the oximes were called as aldoximes, right? Particularly, write it down one note. If H and OH are same side, right? This H and OH, H and OH are same side. H and OH are same side. H and OH are same side, we could say syn, Nana. If H and OH are same side, syn. If H and OH are opposite side, we could say anti. Right? This is obviously syn. This is anti. Write it down. Syn, anti. H and OH are same side, we could say syn. If H and OH are opposite side, anti. Done enough. Right. If it's ketones, Nana. Right? So aldoximes, in case of aldoximes are easy, right? H and OH are same side. But in case of ketones, R dash, ketone, same, NH2OH. The product which is forming over here is what? That is aldoxime, in this case, ketone case, ketoxime. Yes or no? Hello? NOH. So in this case, the ketone, we will take one example. For example, methyl phenyl, double bond NOH, the lone pair. This is one type. And one more type, CH3 PH, double bond N, OH of lone pair is down. Yes, Nana. So now in this case, how can we say syn, right? Syn and anti. Anyone? How can we say? Because earlier I told you H and OH in case of aldoximes. In case of ketoximes, how? Anyone? Online guys? How we have to say, Rana? Which one? How can we say? PH. The groups are keep on changing, right? Anyone? Right. So the OH, phenyl and OH are same side, right? Okay. So what we have to write? Syn, right? Syn, phenyl, methyl, ketoxime. Otherwise, the same compound we can write like this also. Or anti-methyl, phenyl ketoxime. So means we can write two things. Syn phenyl. Syn-phenyl methyl ketoxime, otherwise anti-methyl phenyl ketoxime. So same thing, just let me know this. Syn methyl phenyl ketoxime, anti or anti phenyl methyl ketoxime. Write it down. Anti phenyl methyl ketoxime. Then, huh? Then, which one, Nana? Yeah. Which nomenclature you want? Here, what I'm trying to say, the pH, right? Phenyl, right? pH, OH, same side, right, Nana? Hello. So, if OH is same side means syn-phenyl, okay? Syn-phenyl. So then automatically this is comes later. Syn-phenyl methyl ketoxide. Otherwise, the same. The CH3 is what exactly? Opposite to OH, right? Then this is anti to OH, anti-methyl, okay? Then phenyl ketoxide. For example, same thing. The CH3 is OH, syn side, right? Syn methyl phenyl ketoxime. Otherwise, pH is anti side, right? Anti-phenyl methyl ketoxide. Okay. So I'll give you one more, so you'll get the clarity. For example, ET means ethyl, methyl and ethyl, OH lone pair. Okay. Here, for this, write it down. Everyone try this too. This is tertiary butyl. Tertiary butyl. Come on, try this 4. You'll get the clarity right now. So first one I'll tell you. Remaining one you have to tell. Okay. So first one, this is syn ethyl. Okay now. Syn ethyl methyl ketoxide. Come on, remaining right. Anti anti methyl ethyl ketoxide. Good. Or anti methyl ethyl ketoxide. In this case, here opposite right here, exactly. Syn methyl ethyl ketoxide or anti ethyl methyl ketoxide. Write it down. Here is syn tertiary butyl methyl ketoxide or anti methyl tertiary butyl ketoxide. In this case, syn methyl tertiary butyl ketoxide or anti tertiary butyl methyl ketoxide. Write it down. So if you have any doubt, let me know. Completed? Clear? Okay. Done? Huh? No need write. So shall I? No need to write. Shall I write? Meghna Rasava? Meghna. Okay. చెప్తావా ఇది? Write it down. I'll ask now. Next, no, no. For cycloalkenes now. For cycloalkenes, I told you in the last class. So minimum, how many carbons now? Write it down. For cycloalkenes, minimum 8 carbon atoms are required to show the geometrical isomerism. To show the geometrical isomerism. So minimum 8 carbon atoms are required to show the geometrical isomerism. And 8 to 11, up to 8 to 11, generally trans is more stable, right? But up to 11, up to 8 to 11, cis is greater than trans. Cis is greater than trans. Cis is greater than trans. After 11, trans is more stable. Generally, cis and trans, both the cases, which is more stable means what? Trans is more stable. But particularly in this case, what exactly happens? Up to 8 to 11, or this is more stable than trans. So try to understand. For example, I will take that example why cis is more stable. Imagine, no? So this is cis or trans? Hello? Cis or trans? Cis or trans? Two carbons are same side. Cis. So for example, if we want to write for this trans, what we need to do? So for example, is 3 is this side, imagine 8 should be coming this side, but we are not breaking the bond. So imagine okay, now this is C, C, right? How many are there? It is one more C, it is one more C. So the back side, I'm just showing that yellow color, the back side the bonding is there. We just totally twisted. Okay, when we are twisting, so imagine for example 1, 2, 3, 4, 5, this is 6, this is 7, this is 8. So what exactly happens when it is there, when we are twisting, automatically what exactly happens? Stability is decreasing, right? That's the reason this is more stable up to 11. This is more stable than the trans. Write it down, Anu. First note it down. Yeah, Then, hello. So what about this one? First one and second one. This. Hmm? This is cis same side. Here is opposite side. Trans. Write it down. Cis and trans. The bigger cases also we can write. You know? Next. Substituted cyclohexane. Substituted cyclohexane. CH3H, CH3H none. So this we can write like this also. Both are same side, right? So thick line, thick line means in stereochemistry, thick line means towards observer. No. Dotted line means away from the observer, right? So CH3, imagine CH3. So now we can say this is cis. This is also same cis. Otherwise we can write the same with the dotted line. Okay, all are cis. So how can we write the trans for this? Trans CH3 HCH3. Right now. One is thick line, one more is dotted line. This is trans. So write it down. Cis and trans. Anybody confusing, please let me know. Okay, na? Chandra. Hello. Hmm. Which one? అదే అడుగుతున్నా. ఎస్ చేయదు. This one won't show the GA. This is this. Write it on this also. Then, right. For example, the compound is like this. ClCl H. Obviously, this is what? No. Cis. This is trans. Write it. What is this? Obviously, this. This is trans. Then, next. So, in case of cyclohexanes, a lot of people are confusing here. Cyclohexane actually existing is a different forms. So, actually, this is a cyclohexane, right? Cyclohexane cases, it is in different forms. Most stable form is chair form now. Right? This is a chair form. Okay. Hello. So how should I write? First one slant line, like one more here, then here. Okay. Now, in case of here, try to understand. This is above, below, above, below, above, below. All are axial. What is there? Axial. Axial. So, for example, in this case, this, right? this, 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 this. Equatorial. Equatorial. Write it down. Axial and equatorial. Axial and equatorial. Right, draw the structure. Basically, cyclohexane, what exactly happens, Nana? So, see, uh, here is cyclohexane structure. This particular one, these are all four. One is above and one is below, like this.